Hi, welcome. I'm Servan, a young researcher at Imperial College London, and I'm also part of the Titirici Lab. And today I wanted to show you how we are making sustainable batteries, how we are transforming biomass into energy materials. Come with me. As a researcher, our main task is to find solutions to the challenges of our society using science. Trying to mitigate climate change is not easy. We are still using petrol for our cars and trucks, we are producing electricity using coal and gas, and all of this is constantly producing carbon dioxide which warms up the earth. So what can we do? At Imperial College, we contribute to making the world more sustainable by helping to decarbonize transportation. Batteries are a very important field of research as they can store electricity coming from renewable sources such as solar and wind energy. But the problem with batteries is that they need critical elements such as graphite, cobalt, nickel or manganese, and some elements are quite rare and expensive. In our lab, we are around 20 people coming from all around the world. In our everyday life, we try to come to work by bike, compost our food waste, and eat less meat. Some studied engineering, other material science, and some others studied chemistry. And all of this knowledge allows us to design new materials which will work to store electricity. Every day we share ideas on how the science works and discuss theories to find answers to our questions. The materials we produce must have two main requirements. They must conduct electricity and they must have a specific architecture at the micro and the nanometer scale. Some materials are porous, like sponges, some others are very brittle, and some others are like powders, light and heavy. But all of the materials we do are black because they're mostly made of carbon. Our work consists in using biomass as starting material instead of graphite. This biomass, such as wood, seeds, and various food wastes, is mostly made of carbon and oxygen. And these compounds are both a valuable and abundant resource to produce carbon materials. We transform this biomass by cooking, solubilizing, and finally shaping it into many different nanoarchitectures, which are tiny, roughly 100 times smaller than a hair. As wood contains loads of ashes and minerals, we can also extract the cellulose and lignin from the wood, which simplifies the process and simplifies our understanding. One striking example of the materials that we can produce are nanofibers. These fibers are made from lignin. They are flexible and they can be used directly in batteries. To understand whether they have the right properties, we analyze them using various techniques which inform us about their porosity, their density, their conductivities, and so on. Our job is kind of a roller coaster. Sometimes we obtain good results and sometimes they are less good. But there is always something to understand, something to think about and reflect at the end of the day. We all love science and we find it essential to do what we like so that our job remains innovative and creative.